Welcome to The Explainer. Today, we're strapping in for a journey that's going to stretch your imagination to its absolute limits. When we look up at the night sky, we usually focus on the gentle twinkle of distant stars, right? Or maybe the serene glow of the moon. Well, scratch that. Today, we're hunting monsters. We're going to explore two mind-bending cosmic extremes that represent some of the most awe-inspiring and honestly terrifying forces known to science. We'll start way out there at the very center of galaxies where the laws of physics literally break down. And then we're zooming right back to our own atmosphere to look at the kinetic, fiery threats that occasionally come knocking on our planetary door. So, what are the universe's most extreme dangers? When we gaze up, we get this illusion of a quiet, peaceful night sky. But the reality? The reality is vastly different. It's a chaotic space out there, just filled with dark, unseen traps and blazing projectiles. We're skipping the gentle introductions today and plunging directly into the deep end of the cosmos. Because while our universe holds immense beauty, it is also a theater of unimaginable power and destruction. From gravitational forces that can swallow light itself, to rocks traveling at hypersonic speeds right over our heads, understanding these forces is absolutely crucial to understanding the very nature of our universe. Let's kick things off with the ultimate cosmic trap: black holes. These are arguably the most mysterious, powerful forces in the entire universe. But what exactly are they? Well, essentially, black holes are the ghosts of massive, dead stars. Think about it like this. When a huge star reaches the end of its life, its core collapses under its own staggering weight. Imagine taking an object the size of the Earth and crushing it down to the size of a marble. No way, right? But that total collapse creates a gravitational pull so unfathomably strong, it literally breaks the normal rules of space-time. Okay, let's dive into this. What we're looking at here isn't some artist's wild rendition or a computer simulation. This is the actual, historical, first image of the supermassive black hole located right at the center of our very own Milky Way galaxy. It was revealed to the world in May of 2022, showing this glowing ring of fiery light surrounding a totally dark center. This cosmic giant actually has a name: Sagittarius A star. Now, scientists had theorized it was there for years just by watching how stars behaved around it. But finally capturing this actual image, that was a monumental leap in astrophysics. Now, to truly appreciate the scale of Sagittarius A star, just look at this staggering number: 4 million. That is how many times more massive this black hole is compared to our sun. I mean, just try to wrap your head around that. Packed into a space smaller than our solar system is the gravitational equivalent of 4 million suns. It's exactly this incomprehensible density that gives black holes their terrifying power. Because of that crazy combination of a tiny size and an enormous mass, a black hole acts kind of like an unstoppable cosmic vacuum cleaner. Its gravity becomes so exceptionally strong that it actively shreds and absorbs the mass and light around it. They just pull in surrounding gases, dust, and yep, even entire stars if they happen to drift a little too close. And as they consume all this matter, these cosmic giants just keep growing, feeding on literally everything in their immediate vicinity. But the absolutely crucial point is understanding the boundary of this trap, which brings us to a frankly terrifying concept known as the event horizon. You can think of the event horizon as the ultimate point of no return. Once anything crosses this specific boundary, it is going into the black hole. There is no escape. If you crossed it, you'd undergo a fatal stretching process that astrophysicists actually call spaghettification. I know, it sounds funny, but it's very real. According to the theory of general relativity, the speed you'd need to escape the gravity here is greater than the speed of light. And since nothing can travel faster than light, nothing gets out. This is exactly why black holes are truly invisible to us. They reflect absolutely no light whatsoever. We only know they're there by observing the chaotic light and matter swirling just outside this boundary. So what lies beyond that event horizon? Deep at the very center of a black hole is a concept that literally gives physicists headaches: the singularity. This is the point where all that mass we just talked about is infinitely compressed. At the singularity, the curvature of space-time itself becomes infinite. It's a place where our current understanding of quantum physics and space-time just completely breaks down. It's fascinating, and it's exactly why these objects are such popular subjects in science fiction, even though they are very, very real. All right, we've explored the distant, invisible traps lurking in the dark corners of the galaxy. But what about the dangers that hit a bit closer to home? Let's execute a sharp pivot here. We're moving away from the unseen, theoretical physics of black holes and jumping straight into the kinetic, very visible, and highly explosive danger of space rocks heading straight for Earth's atmosphere. To really understand this threat, we have to trace the brutal survival journey of a space rock. People mix up the terminology all the time, but it actually happens in 3 distinct stages. First up, step 1. When a chunk of rock or metal is just floating silently out in the void of outer space, it's called a meteoroid. Simple enough, right? But step 2, the moment that rock gets snagged by Earth's gravity and hits our thick atmosphere, intense friction turns it into a blazing hypersonic fireball. That is a meteor. And finally, step 3. If that fiery object actually manages to survive the immensely hot trip and strikes the ground, that surviving physical rock is your meteorite. Fun fact, most meteorites we find down here are actually shattered pieces from ancient asteroid collisions. It's super important to contrast these 2 experiences. A meteor, that's an event. It's that blindingly bright flash you see streaking across the night sky, often visible to the naked eye when it's anywhere from 250,000 to 390,000 feet above the Earth's surface. Millions of these hit our atmosphere every single day, and most of them burn up entirely long before they reach us. But a meteorite, that's the physical, dense rock you can actually hold in your hand. It consists of those shattered asteroid pieces that actually landed on Earth's surface. It's the silent survivor of a completely brutal fiery descent. And this brilliantly illustrates the sheer contrast in energy. During atmospheric entry, you have this violent, screaming fireball plowing through the sky. The speeds here are almost incomprehensible. We're talking about the fastest meteoroids traveling up to 94,000 miles per hour. But what's left over is just a dark, heavy, pitted meteorite resting quietly in the dirt. They generally come in 3 common types: stony, stony iron, and iron. It looks so peaceful once it's sitting on the ground, but the kinetic energy it took to get there is just staggering. To put that into perspective, let's look at some major impact events to show just how explosive these rocks can be when they don't burn up entirely. In June 1908, the Tunguska event in Russia saw a meteor explode in the air with the energy equivalent to roughly 10 to 15 megatons of TNT. Fast forward to February 2013, the Chelyabinsk meteor, also over Russia, exploded with 26 to 33 times the energy of the atomic bomb dropped on Hiroshima. And what about the ones that make it to the ground intact? The largest one ever found is the Hoba meteorite in Namibia. It's an absolute monster made of iron, weighing over 132,000 pounds. Now, what's really interesting here is the visceral aftermath. The sheer scale of this kinetic danger is hard to wrap your head around, but seeing the devastation from that 1908 Tunguska event really paints a picture. This wasn't even a crater impact. The meteor exploded in the air before it even hit the ground. And yet, the resulting shockwave completely flattened an estimated 80 million trees over hundreds of square miles in the Siberian forest. I mean, they look like giant matchsticks just swept aside by an invisible hand. It forcefully drives home the incredible, terrifying power these space rocks carry. So, we're left with this final thought. As we look up at the night sky, are we simply seeing a beautiful, serene cosmic dance? Or are we actually gazing into a minefield of unimaginable power? From the silent, invisible event horizons of massive black holes lying in wait, to the screaming, fiery entry of meteors traveling at 94,000 miles per hour, our universe is a place of absolute extremes. I really hope this explainer has given you a whole new perspective on the breathtaking and formidable monsters of the cosmos. Keep looking up, stay curious, and thanks for joining me.